This has probably got to be my favourite Marshall amp of all time. This and its slightly older brother, the 4-hole version, are just the epitome of excellence in Marshall sound. I like the early 800s, but this is where it peaked to my taste, my 70s kid taste, right? So after the 800s, they just didn't float my boat. But this is going to do some good boat floating. So go and grab yourself a coffee, pull up a chair, look over my shoulder, and let's get started. An intermittent power-up issue, whatever that means, we'll find out. And pops are crackly, and we'll check our usual stuff. So we'll go through this amp together and we'll have a look and see what needs to be done on it. Also, the earthing wasn't great on these, so we'll just check and see if this has been tended to at any time in its past, but less of the blah and more of the action. These badges sadly do crack fairly often. This one has cracked, broken, it's been glued. They've missed the connection in a couple of places. That's excellent, excellent. Not so excellent, not so excellent. But I'm not going to try and prise that off and redo it because I'll just make the damage worse. Other than that, the cabinet is excellent. No major vinyl tearing. No, just a bit of grubbiness. Missing a top of knob there. If I can, I'll just replace I've got some new Marshall knobs. I might just pop the cap off and attach it to that if the rest of that body of the knob's okay. Very cool. Rocker switches, 2 instead of 4 inputs. So it's definitely late 70s. Those are the original RS Spares transformers, which is great to see. Drake choke. The daily caps, I think I said LCR, these are the daily ones. What else have we got? What's that little date sticker tell us? 3 of the December 1979. Excellent. Do we have any little gems here? Groove tubes. Groove tubes. Come on, baby. They look like Softex, but no label. Cool, looks pretty original. I'll test these. I'm very conservative when it comes to replacing parts, but when it comes to high consequence of failure parts like these, I tend to err towards the side of replacement. Oh, hello. I just saw a knob fall off, but it is cracked, which is why it fell off. And that one is also cracked. And that's the one with the missing top. I'll take off the knobs because we want to keep this as original as we can. And that includes the knobs. That one's good. That way we can check the tightness of those as well. You can see here there is no 330 microfarad bypass cap that's on the earlier amps, which is way too high and lets in too much flub. And we have here the 10K cold clipper. So called because normally on the load line you try and have the operating point, the quiescent operating point, smack in the middle so you can have equal range back and forward along that load line, which is set up by the tube type, the plate resistor and the cathode resistor. If you increase the cathode resistor when the same amount of current passes through that as it would, say, a 1.5K, it's going to create a higher voltage drop across it, which is going to, in effect, give you a more relative negative voltage compared to the control grid. So it will tend to turn the tube off. So in this case, they've used a 10K here which will effectively make it much easier. So that the tube is now biased not smack in the center, but it's biased cold. The tube will go full normal excursion to the positive, but negative, bang. First it hits the non-linear part as the lines start to cram up towards the bottom, and eventually will turn the valve off. So that's why it's called cold clipping. It's done that to create a greater sense of gain, of clipping. It's also going to give us asymmetric clipping. In fact, some manufacturers, instead of using a 10K cold clipping resistor, will go higher, 20K, 30K, 33K, to exaggerate that clipping off high gain sound even more. Now, generally, that has to be followed up with some other stage to make up, because this is obviously a cold clipper is obviously a lossy stage. I found this schematic on Rob Robinette's page, and he's got this excellent drawing which shows how this cascading gain stage works. So if you look at the low input stage, it just comes through here, through this preamp volume stage, into that cold clipper that we just discussed, and onwards into the next gain stage. But the interesting thing happens with the high input jack. It comes into the grid as per normal, and then at the output of this one, it goes through a coupling resistor, make sure there's no high voltage DC on there. It goes back into the input jack. And so long as that contact is kept very clean, the low input jack, that signal will then come back in here. So it's already had one gain stage. It's now coming in here, going through that preamp volume, and then going up. So by the cold clipper, we've now got two gain stages on the high input jack. It's got that cascading gain concept. So what's going to be our order of work here? First thing I'm going to do is check to see that these 50 plus, are they? Yeah, something like that. Year-old capacitors are still reasonable in ESR and capacitance. Very, very tempted to change them, and I will recommend that we do to the owner, because it's just, we're playing Russian roulette now. Here's that typical Marshall, don't know what we're doing with earth scheme. So we've got our mains earth there being screwed to the chassis, which is also picking up that first ground from that cap. And then we've got another ground to that cap here. And underneath here, where we have our third capacitor, there is another ground to the chassis. So there's all these to chassis ground points all over the place. I know it's a little bit contradictory of my conservator approach, but it will look the way, it'll look right. I will probably solder this wire directly to the chassis, and I know Marshall didn't do it, but I really do not like the way that these connections here just asking for poor contact to be made. So I'll solder that ground wire, then I will try and do a star type of configuration of the grounds as much as possible. So I will common these two ground points. I will just do a good connection there, give that a good rub back and clean, and I'll coat it with nail polish or something like that so that it's not going to come loose, and it'll also prevent some oxidation. With the ground point underneath the circuit board from that big filter cap down there, instead of putting the earth to the chassis, I will put the earth to the input jack, which is where it should be. And then we need to address the customer's issue, which was intermittent power up. You can see here where someone's done some work to hardwire the voltage selector to 240, which is good. I like that. Doesn't look the best, but I just can't find one that will fit neatly. I've tried 2 different ones and I've always got to do some mod or other to it. The fact that that's already there and doing a job, I will probably leave that. Well, first thing we'll do is just to check to see what's the story with this power switch. Intermittent power up. Okay, we've got no light on. We've got power coming in here. That should be the switched power there. Okay, so according to my bench meter, we have got power and that lamp is on. Hard for you to see unless I shade it, and then my hand is blocking it even worse, but it is on. So we'll just keep an eye on that as we start to test other things out. And let me just check. 389, 390, 383. Okay, so power supply is working fine. I may need to change that switch. I've got to see if I can make it play up first. And meanwhile, I'm going to call the customer and see what he wants me to do in terms of the other tasks, which I'd like to, in this case, replace those caps. Let me just measure them before I call him. I'm going to just use my ESR meter and I'm going to set it to electrolytic capacitor. Sorry you're not seeing this, but 1 kilohertz, 120, 100 hertz. We'll have a 100 hertz ripple on those. Delta Q theta ESR, here we go. 50 at 500. You want to see less than 2 ohms. That section there is 1.5. Same, 49 microfarad and 1.5 ohm. And this will read 100 microfarad because you've got 2 parallel. 100 microfarad should be less than 1 ohm, and indeed it is. 0.6 of an ohm, and reading 103 microfarad. I can't get to the 2 contacts for that filter cap under there, but I can reach where they join up. And so what we're going to do is we're going to look at the other side of that 100K from pin 1 and the other side of that 100K there. If I measure that, we should see 50 ohms, 48 at 1.6, 1.7, and that one's 49 at 1.7. So I'm going to say, in my opinion, we should change these only because they are fairly critical to the security of the amplifier and the noise, etc., etc. But they measure okay, they're still strong enough both in capacitance and ESR. So if this is a non-gigging amp, I would say let's leave them in until the next service. Or if it is a gigging amp, I'd say let's replace them. Might as well check the bias caps while I'm here. 10 microfarad at 100. We want to see around about 2.5. That one is 5. 4.9, so that one's got to go. Both of those bias caps need to be replaced. High ESR, which means the internal resistance is higher than suggested maximum. And as you know, when current passes through a resistor, it generates heat. As you know, heat is the enemy of a capacitor. So here, we've got the enemy within. So those two are going to go. These capacitors will be fine for the cathode bypass. These coupling caps, probably they'll be okay. I'll check those. These two I'm going to be a little bit more critical on, because these are the ones that will be blocking DC to our power tubes, and that's a critical application. All right, I called the owner and left a really long message. I probably bored the poor guy to death. So I'm just going to set this amp aside because I wanted his direction on whether I will improve these grounds or leave them as is. And even more importantly, whether he wants me to replace these capacitors. And basically the question is this a gigging amp? If it is, we'll change them. If it is not a gigging amp, then it's up to him whether we change it or we leave them go and just keep an eye on them on a regular service. Every 18 months, it'll cost him bugger all for me to just pull it apart to this level and just check the caps, clean the pots, clean those jacks, the input jacks, because as I mentioned, they are critical, especially that low input jack, to the effective operation of that sequential gain stage, cascaded gain stage. All right, I'll set this beauty aside and start on something else. Okay, I've spoken to the owner and he said he will defer to me in terms of what I would do, and basically just to treat the amp as if it were my own. In that case, even though these main filter caps are still testing okay, in terms of both capacitance and ESR, which is just amazing. But I've seen this fairly often with these old British amps. They just had great caps. But what would I do if I owned this little gem? They do not affect the tone. Unless they are starting to fail, then they will affect the tone. I'm going to replace the 3 caps with some new F&Ts. Now these we did find were high ESR, faulty, and I'm going to replace both of those with a couple of Spragues. To do that, I need to lift the board up. So while I've got the board out, I'm also going to reposition the ground on a couple of these points. I want to do a more solid mains earth connection to chassis, so I will do the old Fender approach, and that is I will solder that mains earth wire directly to the chassis. Then instead of having all these myriad of earth connections there which cause hum, I'm going to do a star earth connection, say there, where I will run those grounds. I think we've also got the other center tap for the transformer coming there as well, so I'll just convert that to a star ground. Likewise, while I've got this board lifted, I'm also going to reposition the ground on that, take it off this stupid sort of chassis ground thing, and run an earth lead directly to the input jack. I will cut this wire here and run all of the grounds like that earth to there, the capacitor earth to there, and then we will do a one solid ground to the chassis. It'll do all of the input jacks, the volume, preamp volume, that main filter cap at one point, and then I will try and make a bit more sense out of this. I'm not a huge fan of our signal earth being connected by this bus wire, which we're then hoping is creating a good earth to the chassis through that pot. That's not the intention of the pot. So probably what I would like to do is connect all of the signal grounds and take them all back to that star ground that we're going to do back here. Let's get on with it. I'll start my little timer. I use this program called Toggle Track to keep a log of my times. I used to do it on the phone, but I'm really liking this program. Aside from the fact that it's free, I can write descriptions beside each one of the blocks of work that I do. So when I'm going to make the invoice up for the customer, it's a more meaningful description of the time I've spent. And not that I'm ever going to get any corrosion there, but let's give it a bit of belt and braces and just put a little bit of my nail polish. This one's clear. Now, that one's ready to come out. Look, this is pretty straightforward. I might just turn this off while I'm doing this. Just nothing much in here for you other than just getting bored. You might be able to see here why I'm not so keen on the nut and bolt type of grounding method. You may be able to see there's already gunge build up on there. We had before gunge built from there to there, and then from there to there, and then from the centre tap to there. So all these gunges create poor earths, which will lead to noise. What I'm going to do now is I'm going to just grind some of that coating off. I'm going to put my little star connector thing on there, and then I'm going to solder from there to there, from there to there, from here to there, and then I'm going to put, you know, my nail polish, not my Friday night red, but just my Thursday night clear nail polish on top of that, to try and keep the moisture and any gunge off that connector, to try and keep that corrosion and gunk build up to a minimum. Got that bit there. This is a capacitor that's under the circuit board, and quite often, especially on the newer Marshalls, where they were just so cheap that they wouldn't give you enough lead to come out like this, it was a real challenge to get on. But this one, it'll be a piece of piss to just unsolder these. I'm going to ditch this ground wire because it is just screwed to that chassis point there, and instead I'm just going to cut a longer length of that black lead, and we're going to take it to the front panel here. I want all of these with that ground lead all going to the one point, and that's going to be basically our preamp ground.
Well, I lost audio here, so let's see if I can remember what I was talking about. You can see the star earth connection I put there near the main filter caps. So I've got all of the grounds running to that one point. You can see the soldered earth connection. You see, it can be quite misleading on a schematic where they have all of the different earth points for the capacitors. And Marshall took it literally and put all these different earth points all over the place. Whereas those filter caps, all those grounds should be going back to the one place for the power section, you know, like the power tubes, the phase inverter, and we should have another set of grounds for, or another ground point, star ground point, for the input section. And here we're looking at the input stage, and up the top you can see the filter capacitor that's underneath the circuit board. It's just showing a random connection to ground, but now all those ground points for the input jack, which you can see there where it says low, and then there's a ground point high, and there's a common ground point for all of those, and the cathodes, the cathodes go to those ground points as well.
All right, let's have a quick look at what I've been up to. So here is our new star earth point. So this being a 50 watter, it's a bit simpler in terms of its filter caps. A complexity with these is the fact that using the dual can caps, we've only got one ground point to the capacitor for two high voltage sides of the capacitor. So it's only got 3 caps in here, 3 doubles. So I'm basically dividing the amp into preamp and everything else. So I've got this new secure ground connection here. I've cleaned off the coating here, so I've got strong metal-to-metal contact between the star connector. I've got double nuts here. We've got the nut and basically a locking nut. I didn't want to put any coating on there because this connection may need to come off at some stage in the future, so I've just got a nut and locking nut on there. You'll see a whole bunch of grounds now coming to one point, and that's important. So we've got the cathodes for the preamp stage, both coming there. We've got the ground for the big cap, that's just under there, that's going there. We've got the ground for the input jack, that's important that that goes there. And then we've got ground for the preamp volume. So that's a new wire I've put in. So now any pot that has got a ground on it is no longer, I haven't done these yet, going to be connected from the contact through that bus wire to the casing, which is not a secure ground, through the shaft onto the chassis. So I'm now going to link those up directly, and you'll see that in the later shot. I've been testing all of the components, and I've only found 3 components that have drifted significantly away from spec, and by significantly I say 10%. So that's, this one's going to get replaced, this one's going to get replaced. This one was still in spec, but seeing I'm going to have to be replacing this one is obviously, well, it was well done, but you know, connected from above. I just want to make that a bit neater, and I'll do a proper solder connection from below. And there's another resistor over here. Coincidentally, all of them 100K. So that one's just out of shot there. And that's all there was with the resistors. I haven't checked the coupling caps yet. That needs to be done under power for my way of doing it. I've got no problem with the bus wire grounding out the covers of all the pots, because that acts as a nice little Faraday shield around the potentiometer. But as far as the signal grounds go, like here, here, and the presence pot where I am here, those I'm going to have directly connect. I'm just going to link these ones together, and then going back to my star point near the main power supply. So that should significantly improve the ground noise. Let's get to it. Here are those 2 100K plate resistors that I replaced. I used these Vichy metal filled ones. They're brown. They look very similar to the old carbon comp ones, and they're going to be a lot quieter if they were noisy. We haven't even powered this up yet. This one, which I was going to replace, once I pulled it out, I measured it at 104.7 instead of 100. That's less than 5%. So I thought, no, you're staying. So I straightened the leads, put him back in. I'll clean off my little black mark too. What I was saying about the grounds on these pots, it's just inadequate grounding to use the pot shields, pot covers, as a ground. For example, ultimately we're going to be measuring the resistance between the shaft and the chassis, and then the shaft to these folded over clips there on a pot, and then to the pot shield to that solder joint there. So if I measure this shield here, it's 0.87 ohms. If I measure directly to the chassis, it's 0.2 ohms, 0.1. So that's the resistance of my leads. Like that's 0.5. Touching my leads together, 0.1. So already we've got some resistance here. This one here, which is now on its own, that cover is now 3.7 ohms. That's how bad taking an earth off that pot is. So we're going to improve this significantly. So you can see we've got quite a few wires here. We've got 1, 2, 3, 4, 5, 6, 5 wires going there. And on the other star pot at the other end, probably about the same. So I think that's right. I'm just going to measure out the grounds now, make sure I've got ground everywhere I need to. All right, I think this is going to be much better. Now, one thing I've noticed is that all of these standoffs are loose. So I'm going to flip this over. Oh, that one's tight. But all the others are a bit loose. So I go flip the board over, flip the chassis over rather, tighten them up. Then I'll come back and tighten up all the transformer bolts, any other mechanical bolt. The caps I know are already done. Then, for the first time, I'm just going to apply some power on here and make sure that all of my connections are good electrically. going to show you this first. I made this thing, God knows, 20 years ago or something. And it's a former nail file, I think. I just ground down the edges so it would fit in this space here between these cliff type of connectors. And I sanded that pretty smooth. There's just a slight bit of grit in there. God knows, I'd guess 1,000 grit. It's pretty fine. And you may recall it when we were talking about the way this picks up an extra gain stage by looping it back through the low input jack. And that's why it is really important that this connection here be kept very clean. So a bit of IPA, isopropyl on there. Open up that connector with just a normal 1/4 inch jack. Just a couple of rubs like that and it's done. Do the other one. And just close it up. Just the pressure of the spring itself is enough. And that's it. So that's going to give us a really good connection now for when we want to do that sequential boost. I'll do the other high gain input as well. And then we'll put that back in. Oh, now, interesting point. Pretty much all of the transformer bolts were loose. It's just the vibration over 50 years. So please make sure that you just check the mounts and also the cheesehead bolts that compress the transformer windings, laminations together. They had also come loose. The choke, I guess just smaller, who knows why. It was fine, all those connections were tight. But both of the big fellas, I guess because of their mass, had just come loose. And you know, these are just finger tight. So it's just plastic to plastic, so don't hang off that monkey boy. Oh, we're getting close. When you know you're looking at knobs, we're getting close. So this one has got a couple of big cracks in it that have been glued before, and I reckon we can get more use out of that. So using a bit of super glue, I'm going to just close up those gaps a little. And so I'm not left standing here holding it for hours. I'm going to use some accelerant. And that's it, job done. So that's that one done. That one looks fine. That looks good. This one's got a big crack that's moving. So we'll give him some glue. Close it up. Hold it for a few seconds while that sets up. This is silver top. Now, it's not exactly the same. This has got a pointer on it. This doesn't have a pointer on it. And that one's brown. And this one's black. Let me have a look at the gold ones. These are the gold ones. Also no pointer on that. The original is 1513. This one is bigger. It's almost a millimetre bigger. You know what? I'm going to save my judgment until I've got the knobs on the amp, and then I'll make a decision. Put the tubes on the tube tester. Unfortunately, they have drifted a fair way apart. I'm assuming they were, of course, perfectly matched when they went in. And normally, obviously, an ideal match is zero difference between the plate current and the transconductance. But for matching, I basically just keep it simple and look at the plate current. I normally would say, obviously, 10% is perfectly acceptable, 15% is okay. But this is looking to me more like 25%, I'm thinking. 29.5 divided by 23.3. It's 27% different. Ouch. Well, what I'm going to do is I'm going to put them in the amp and I'm going to monitor the actual plate current going through them, because this is a pretty good indicator, but yeah, an amp itself is not perfect. So I'll try them in both positions and see if I can find a close enough match bias-wise, and I'll also check it on the oscilloscope. Hopefully I'll get a bit more life out of them, but if not, I'll have to break the news to the owner that we'll be up for this, as well as all those other things that we've been doing. Okay, let's get this back together. I've cleaned the tube sockets. I've tested the power tubes. I'm now going to start ramping up the variac voltage. Now, I'm not going to just flick 240 volts onto this power supply, because these capacitors have been asleep for several months. So I'm just going to slowly start winding up the variac. I think we've got a noisy V1. That's a lot better. Yeah. So I'd say at the very least, preamp tube number 1, shears are gone. Next thing we're going to do is put on my bias checkers and just see what sort of current we're drawing. I think I might preempt that by winding my bias voltage cold as I can get it. Minus 32, that's minus 33.8. We need to do some checking here. I think I'll put those bias checkers on and see what current we're actually drawing. I've got the bias checker on and it's reading 41 milliamps and 47 milliamps. And that's reflected in that different plate current that we saw. Put it on the oscilloscope. I've just got the bias in on both those tubes, so I mean I can hand it back to the customer saying it's biased, but obviously not ideally. Right, let's see what this is. So the tube on this side is 358 volts by 0.041 amps is 14.7. Divide that by 25. So this tube is 58.7%. And the one on this side is 0.047 amps times 358 equals 16.8. Divide that by 25. And 67%. So therein lies our mismatched tubes. We've got 67% and 59%. Not ideal. But wait, there's more. I don't know if you can hear that noise. That change in noise is just me touching V1, V2, V3, fine. V1, and that's just gently tapping on V1. We're on full volume, both volumes on full. I'll go grab a new V1 and hopefully that will sort that out. I replaced V1 with a Tube Amp Doctor 7025. I just want to check to see if I've got any noisy components. Okay, we've got a bit of a lead dress issue here. Just try and keep that green wire, just moving that a little bit to improve the noise, as you may or may not be able to hear. That's the control grid. That's probably the most sensitive wire in the amp. So we want to keep it away from the heater wires. It's sounding better already. Hello. I think that 100k resistor is going to get swapped out. I think I'll just keep that control grid up here and out of the way. Okay, I think that's the only one that I can see that's microphonic. Mind you, this is full volume. I think if I turn that volume down, if I unplug the guitar lead, it's dead quiet. I think that earthing treatment worked a treat. You wouldn't even know that was on. I'm still going to change that 100k there. I think my work is done. I will call the client and see what he wants to do about those power tubes. I mean, they have biased up, but quite a big mismatch. I replaced that with a 100k metal film Vichy. I like them because they're brown, they fit in with all the others. You probably wouldn't even notice them. Put another two in where? Here for the 2 plate loads on V1. All the other resistors were fine. There was one that I thought was dicky there, but once lifting one leg and took it out of circuit, I saw that it was actually perfect. I tried cleaning the preamp and master volume with deoxit and flushing it out and blowing it out, and it just wasn't cleaning up. So I replaced both of them with new CTS 1 meg pots. This is going to go back in the enclosure now. Now it has a metal plate at the bottom, so it's important that we have good metal to metal contact, because that metal plate is going to provide the shielding across here. So we were picking up noise from the ether, which will be blocked by that metal shield. So I'm going to give this metal bracket here, and certainly these captive nuts here, a good clean, so that we can improve that metal to metal contact between the chassis and that metal plate at the bottom of the cabinet, to maximise our shielding for noise. And then I think this should be quite quiet amp. I'm very happy with the results of the earthing, the grounding that we repositioned and made right. Just check out the dB meter. I'll turn the guitar volume down. Check out the volume of the dB meter. 42.5. I reckon we can go a bit louder than that. I've got preamp on, I'll put preamp on 6. Oh, this is going to be loud. Master on 5. You can hear all the buzz now, but that's from the guitar. See? $112 I saw. All right, I'm just going to stand a little bit off to the side so I don't blow my hearing out. I reckon if I put the master on full, we get even more of that beautiful organic goodness from the EL34s. This way we're going to have a mixture of preamp and power amp distortion, but I know this is going to be ear-splittingly loud anyway. Marshall amps, Gibson guitar. That can only mean one thing, plus I'm in Australia. So that can mean 2 things. No, it's still only meaning one thing. AC/DC. I'm feeling the need. I'm feeling the need for a Stratocaster. Oh, you're not going to believe what I just found. Must admit, you don't see me playing the Strat too much. They're a great guitar, and this one's extra great, but they're just so common. This is extra great because I used to own a 1961 Strat, and I was too chicken to take it anywhere. So I asked Lindy Fralin to make me one to the measurements of my 61 Strat, and he made this. I reckon it sounds better than the 61 Strat. As far as I'm concerned, my generation anyway, there's only one player I can think of when you think of Marshall and Strat. Okay, I've just thought of another one. But the one I'm thinking of most is... Need to do some work on this Strat. Well, I hope you enjoyed that sound sample of this absolutely beautiful, historically important Marshall amplifier, JMP-50, 2204, 50 watter. I love it. Love the sound of it. Marshall should have hung up their soldering irons after this or the JCM 800 version of it, and they would have remained legends instead of putting out crap. I hope you enjoyed this video. I loved making it. If you got anything out of it, could you please give me a like, do me that honour, and subscribe if you haven't already, because I'm looking forward to seeing you again on the next video.